Hey there, fellow makers and creators. Welcome back to my channel, and if you're new here, I'm happy to have you join me today. I've got an exciting story to share, and it's all about my journey into the world of CNC machining. You know, I bought this CNC well over a year ago, and when it arrived, I was excited. I assembled it, and it just sat there for close to a year. I was as green as they come when it comes to CNC machines. I had never even touched, seen, studied, or had remotely anything to do with this machine or any other CNCs for that matter. But all that changed. A couple of months ago, I decided to pull my finger out and really sink my teeth into it. I got to learn my CNC machine and all the intricacies involved and how to operate it, how to put what's in my head to a digital format, to CAD, which is computer-aided design, then follow it on to CAM, which is computer-aided manufacturing, and then from the computer over to the brains of this bad boy. This is my Mekanika Evo-M, my first ever CNC. This journey was filled with challenges, learning curves, and many late nights. In the upcoming video, I'll be taking you through my process of designing and cutting a project. We're going to keep it simple. I did want to go through a more complex design. Well, it's not complex on the grand scheme of things, but for me, it's a more complex stage of where I'm at. But I thought I'm not really qualified to do that. And what's better than just keep it simple, show you a project that you can do on your Evo-M or any machine above that. With the festivities coming up of Christmas, we're going to keep with that theme. So with that being said, let's take it over to the computer. Hey guys, we're over at the computer. So let's just jump straight into it. We're using Fusion 360 from Autodesk. It's a free software and it has a paid service as well, but here is the free one. Okay, so the first thing I did was choose a plane face. I chose XY because that's how it's going to be laid out in front of me on the CNC machine. Okay, so when I'm designing stuff, I've always been taught that you break down what you want to design into simple shapes. So here, I'm just going to set up a simple triangle. I chose the polygon tool and I'm entering how many sides I want the polygon to have. 3, so that makes it a triangle. I'm now going to repeat this step 2 more times. If you can guess what I'm designing, leave your answer in the comments. I come from an Adobe Illustrator background, so I've been forcing myself to use this Fusion 360 design process. It's definitely a steep learning curve, and it's very different from Illustrator, but it offers some really good features which I still need to get my head around and become familiar with. And I can definitely recommend you do the same if you're new to Fusion 362. So if you haven't guessed already, we're going to make a Christmas tree. Here I'm just doing the trunk or the stem, and then we have the essential shape of a Christmas tree, as you can see, which composes itself from 3 triangles and 1 rectangle. Now I'm just going to move the triangles until aesthetically it's pleasing to my eye. To do this, I've just selected the move tool, clicked the point I want to move and proceeded to move it. Okay, so now we have the basic Christmas tree shape. What we have to do next is unify all the shapes into one overall shape, which is the Christmas tree. To do this, I used the splice tool. As you can see, it's highlighted by some scissors, and I've just gone inside the design and cut out all the unessential lines. This leaves one toolpath for us to follow in the future. Now I'm just adding a circle which will represent a hole in the final piece. To do this, once again, you select the circle tool and place where you want the circle. Okay, so we finished the sketch. Now time to give it some body. To do this, we're going to extrude the overall shape we have created. So we click the face we want to extrude and enter the height at which we want to extrude it. In this case, it's 15 millimeters. We can also use the arrow prompt and just drag it out until we're happy. Okay, so now I'm going to click the home button. This takes us to the home position. And if you're ever lost in your diagram, in your design, just click the home button and it returns it to this state. Now I'm just going to introduce some roundovers on the corners. In Fusion, these are called fillets. So what I'm doing, I'm selecting each edge I would like to fillet. In this case, it's 6 edges. I put a radius of 10, but I didn't like it, so I went down to 5. I'm a lot happier with that now. Okay, so now time to do the same for the inner corners. Because it's a round bit, you're unable to do sharp turns. So what I like to do is put a small fillet to make it a smoother cut. Okay, so that's looking better. Now just 3 more edges to fillet. What we'll do, we'll start with the nose or the tip of the tree, and then we'll finish with the trunk. As you can see, I just used the arrow to choose the radius size I wanted. And again, I'm just using the arrow to get a nice round over for the trunk of the tree. Okay, so we're nearly at the end of the design process. We have a couple more things to do. I want to check the size, so I go to the inspect window and I click from one end to the other. I get an overall dimension in length. I'm not happy with this, so I've decided to scale the whole design up a little bit. I'm just using the arrow to make it a little bit bigger, and then I'll retake the dimensions. Okay, so I'm pretty happy with this. Let's take it to the next step. So we've finished the design. This is computer aided designing, so that's CAD. We now need to find the toolpaths and find the manufacturing route. So we go to the manufacturing tab, and this is where we begin to find the toolpath. This is called CAM, Computer Aided Manufacturing. So after clicking a new setup, we're presented with our design, but with a block around it. Now this block is the stock, and what we need to do is determine the XY point where we want our CNC to start, and this is where I've chosen it, on the bottom left. I like the bottom left because it naturally chooses the X and Y axis along with the Z. So if you're using your Mekanika, you're going to have presets given to you, which you can download from the resources page on the Mekanika website. I've done this and I've chosen the machine preset Evo-M, which matches my machine. I'm now just changing the offset of the stock, which is this light yellow box around my design. So I've given it a 10mm offset all around the perimeter of my design, as you can see. So this leaves me room to fasten it and secure it to the spoil board. Okay, so let's program the code that's going to tell the CNC machine how to cut this piece that we've designed. First of all, I'm going to tell it to mill the hole. And to do this, I'll use the bore function on the drop-down menu. I click the face of the hole, and then I go to my tools menu and then choose the bit I'll be using. In this instance, we're using a 6mm bit, and the presets, like the machine presets, can be found on the Mekanika website. And for this particular bit, I've chosen the hardwood preset because we're going to be using hardwood as the stock. The beauty of these presets, if you're a noob like me, you're not going to know the feed rates and the speed rates and this and that and all the technical specifications for each bit and how to run them. So these give you, as the title suggests, a good preset, a good basis to start with. You can fine tune it as you develop your skill level, but it really gives you a good starting point of how these bits work, how the machine works, and the speeds at which it operates, especially under what stock you're going to be cutting. As you can see, while I was rambling on, I adjusted the retract height to 0. This I find I have to do because the clearance on my machine isn't that much, or isn't as much as I'd like it to be. So what I do, by zeroing the retract height, I find it doesn't give me errors where the Z-axis has its limits reached. So if you're finding yourself hitting those errors, that's a possibility where it could be. Or if your stock is just too high for clearance, that could be an issue as well. Okay, so the great thing about Fusion 360 is you can simulate the toolpath and see how it's going to behave on the stock. Here, we're in a simulation and you can see the bit just boring out the hole. One thing to note, it will only simulate the toolpath that's highlighted at the time, unless you have the setup highlighted, where it will then simulate the entire process from start to finish. So next what we're going to do is highlight the contour. This basically cuts the outline of the shape. Here I'm mistakenly selecting the wrong contour, but I will fix that in a moment. A point to add, and something that got me confused for a long time when I first got into this, the red arrow that I clicked is the side the bit is placed to cut. So depending whether you want it to cut on the inside or outside, you click it appropriately. In this case, we want it to cut on the outside, hence the arrow being on the outside. So at the moment, I have two contours selected. I'm just going to change that by deleting one of them in the control panel on the right. This leaves me with the correct contour left to cut. I'm now introducing tabs. Tabs are used to keep the piece affixed to the stock while it's cut out, so it doesn't shake and get caught up in the bit. I would say in most cases you should always use tabs, really depending on how you've affixed your stock, but I would say generally always use tabs. You can let Fusion 360 designate how many tabs is needed, or you can click down and choose tabs by number, and then you designate how many tabs you want. Here I'm just going through the options and looking for what I think is the best amount. Okay, so I've decided on having 6 tabs. Now I'm clicking to the stock page and just adjusting the retract height as I did before. This is to ensure no failures during the cut process due to the Z-axis height clearance limitations. Okay, so now I'm on the passes page and we need to select multiple depths because cutting the whole contour in one single pass will surely break the bit. I set maximum roughing depth to 2mm because I like to err on the side of caution. This just means that on each pass it's going to go down by 2mm. Okay, so I deselect lead in and lead out solely on advice from Mekanika. I don't fully understand what it does. I also select ramp. I believe this is the transition from the finishing cut to the next depth and at what angle it travels. I believe it's 2 degrees. Okay, so that's the contour cut done. I now think it's time just to simulate it to make sure that has no problems or issues. You can see it does what the name suggests and just follows the contour of the piece. I'll speed this bit up because it's a bit boring. Okay, so that's the contour cut finished, in the simulation at least. Everything looks okay and there were no problems. So now the next thing to do is just export the G-code. For this, I click the setup, so it includes the boring function and the contour. I go to the Actions tab, click the center icon, and it gives me a prompt. I enter the file name and click Export to a location of my choosing. So this is where we turn the CNC on. Okay, so the CNC is now on. Excuse my voice, I'm just getting over a cold that my little boy gave to me. So now that it's on, we're just going to quickly go through the fundamentals of the CNC. Okay, so the CNC consists of 3 major factors in terms of travel. We have the Z-axis, which moves the spindle up and down. The X-axis, which moves the spindle from left to right or right to left. And the Y-axis, which goes front to back. And we can see this by moving the buttons on the keypad. So if we go for Y, it moves away from me and towards me. X will go to the right and the left, while Z on a separate keypad will go up and down, up, down. Generally, what I like to do when I switch on the machine is bring the spindle back to its home position, and the home position is predetermined by this center button on the console, and it usually sets it at the bottom left corner. As you can see it moving now. Once it gets to home, I like to square the machine, so that makes sure the axes are in all equal distance, so when it cuts square. So we do that by pressing the triangle button on the center console. That's now done. What I also do, especially if I'm changing spindle, is I zero the Z axis. What this essentially does is measures the distance from the tip of the spindle to the top of the spoil board. And it does this using this little device. Let me just make sure it's in focus. Now this device has a predetermined depth. An algorithm takes this into account. So when the tip of the bit touches this surface, it closes the circuit and it can determine how far this bit is in relation to the top of the spoil board. Now to form that circuit, we use this crocodile clip and we attach it to the bit. We then place this button or pad or sensor or however you want to call it underneath the bit, and we press the ruler. It slowly brings the spindle down until it just lightly touches the button. Upon touching the button, it quickly retracts. So now that's the Z done. Okay, so now that we've come from the computer with the design and key, we need to transfer it from here into the CNC. Now to do this, it's a simple, straightforward process. I put my key into the USB hub, which I have connected to the computer. It then prompts me to go into the folders and look at the files, but I don't do this. I cancel that action, and within Planet CNC, I'll go to the menu, I'll go File, Open, wait for the prompt, go to my USB key and find the file that we exported. In this case, it was an Xmas board demo, and I click OK. It's now loaded up. So we have the file in the system, ready to go. We just have a few more parameters to set and it'll be ready to cut. Okay, so we have the stock, and when we made the design on the computer, we did it so it's 15 mil deep. So I have prepared this to be 15 mil in depth. This is a lot bigger than the actual stock we programmed in, but I'm just going to use it because we might cut too. Okay, so how I attach the stock is by drilling holes in the corners and using screws to affix them. I've seen some much better ways. Mekanika even have a new option with these composite nails that looks really good. I might add one here actually. It's a long board. I want it to be secure. I don't want it to lift during operation. So I keep my spare screws in a cup or in an aerosol lid. Just gently screw it in. And I know they're not going to interfere with the cutting procedure because we mapped it out so that the XY point will be on one of these pivots and the design will be cut in the middle. And now what we have to do, we're going to set the XY. So how I set the XY, I bring the spindle to the front. And generally, if I know the XY point is going to be well out of the way of cutting, I'll set it just above a screw, like that. And then I press the XY on the console. That repositions the pattern, so it cuts it how we programmed. I'm just going to move the spindle out the way. We have the 6mm bit in the spindle, and I'm just going to put the dust shoe on and push it back. And when it starts, it's automatically going to go to where I set the XY. It's going to get very noisy in a minute. I switch the spindle on, I attach my vacuum, I get my chip guard ready, and we are good to go. So all that's left for me to do now is turn the vacuum on, turn the CNC on, and let it do its thing. So vacuum on, CNC on by double pressing the play button. And that is the project finished. So the CNC will automatically lift up the spindle upon finish, and I tend to just fully lift it, push it back to get enough clearance, switch the hoover off, switch the spindle off, and then we can inspect the cut. So we have our Christmas tree. Let's take a closer look. So as you can see, we have tabs. In incremental places. So we now have to remove the stock and cut the tabs off so we can lift it out of the stock. And these are tabs. Just keeps the piece secure in the stock. We have the stock. We have the cut, so we cut the tabs. I use my trusty chisel. What I like to do on flat edges, I butt the chisel up to the edge and tap. This way, I get as little of the tab left on the finished piece. Some pieces I can't quite get to because they're rounded corners, so I'll just cut as best I can. But for the tabs that are on a straight, flat edge, I can cut them flush. And I believe that's everything. So as we can see, the tabs are pretty flush here, but where they're on a corner, they haven't cut. But we can fix that with the router and a flush trim bit. So here we have it, one Christmas tree. Maybe we could have made the handle a bit longer. It's quite nice. So all that's left for me to do is put a round over on the edge, flush trim the remaining tabs, put a round over on the back, finish it, and it's ready to give to someone. Hey guys, so this brings me to the end of my video. I hope you found it useful and beneficial of some sort. I just want to stress that it's not so much a tutorial, but more so a process of the steps I go through. I'm by no means a professional or even semi-pro on this subject. These are just my self-taught methods with a little help from the useful guys at Mekanika. Well, actually a little bit more than little help. They've been a great help, especially I'd like to shout out to Arnaud, sorry for the pronunciation. But he was a man who helped me through the little technical issues I've had that were user error on some parts to be able to achieve, you know, my final result, which is simple. Sometimes the simple things in life are what counts. So moving forward from this, I hope to explore my options with this machine far more. I would like to maybe push the limitations with the scope to potentially upgrade or expand on its capabilities. I've thoroughly enjoyed the journey. It's just early days yet. And if you're new to CNCing, I'm sure you're going to be finding it just as frustrating, but equally just as rewarding as I have. It's well worth pursuing and persevering. Just don't give up. It is a steep learning curve. So to wrap it up, if you've enjoyed the video or have gained something beneficial, please consider smashing that like button. It means a lot to me. And if you'd like to see more videos of me and my CNC and other woodworking projects, please consider subscribing. Every little helps. I've linked the project file to cutting this tree in the description. So feel free to take it and amend it or use it as is. If you have any questions, leave them in the comments. And I'm sure there's plenty to critique in the video, so please be kind, and no doubt I'll be learning a lot more moving forward. I'll also leave a link to my machine, and there will be others there, but it's the main link to the Mekanika website. Once again, this is the Mekanika Evo-M. It's the middle-sized machine. You have small and you have large, and then you step up to the Pro version, which is maybe something I'd like to consider in the future, but for now, this is pretty capable of my needs and my abilities, more importantly. So guys, until the next video, take it easy, happy woodworking.